Let's see how many ones we have here. 14. So today, inshallah, guys, our lesson is reaction rates. That's our lesson today. So we will start with this one. Let's start participation with you. Start sharing.
In this video, we're going to look at the rate of chemical reactions, which just refers to the speed with which the reactants get turned into products. And we'll also see how we can measure this rate and how to...
So reaction rates means the speed at which the reactants will turn into products. This is reactants. They will turn into products. How fast this transformation, how fast this reaction happen. The speed of the reaction, we call it chemical reaction rates. How can we measure this speed? That's our lesson today.
Show it on graphs.
So these graphs, one way we represent the speed of chemical reaction is graphs. There is time and here volume of the compound or products. Volume of products here. We will put it here and see what's happening. Or volume of products or volume of reactions, whatever you will start with. If you start with 0, so it will be products. You have no products and you started to increase the volume of products because you start from 0. So this curve here represents the volume of products.
First, though, it's worth understanding just how much the rate of reaction can vary. For a slow reaction, think of the rusting of iron, which can take years or decades. A more typical rate is something like the reaction between magnesium and an acid, which produces a gentle stream of hydrogen bubbles. Then at the other extreme, we have explosions like fireworks, which take place in just a fraction of a second. In order to actually measure the rate of a reaction, though, we need to measure either...
So I'll give you 3 types of reaction according to time. Someone takes very long time, like iron rusting. Sometimes take typical time, like reaction between magnesium and acid, and gentle bubbles of hydrogen gas evolves here. And someone takes a part of the second to happen, like fireworks and explosion. Okay, this is very fast reaction. So we have 3, we can say, categories of speed, or 3 categories of acid of reactions according to the speed.
How fast the reactants are being used up, or alternatively, how fast the products are being formed.
These are 2 ways they can be used for the same thing. They used interchangeably. How fast the reactant are being used. We use reactant. So how fast the reactant are being used, or in the same time, how fast the products are being formed. Both of them represent the chemical reaction speed. Because while you are using reactants, you are producing products. So we can use both of these definitions to represent the speed of chemical reactions. How fast the reactants are being used, how fast the products are being formed.
Because the faster the rate, the faster the reactants will be used up and turned into products. So in the form of an equation, we have 2 options. Either we can say that the rate of reaction is equal to the quantity of reactants used over the time it took for that change to occur, or that the rate of reaction is equal to the quantity of products formed over time.
Alaikum assalam wa barakatuh. So both of these equations represent the same thing, guys. They are not giving 2 different answers. They are the same answer. The rate at which quantities are being, the rate at which products are being formed is the same rate at which the reactants are being used. So the rate of forming products is the same rate as using reactants. Both of them, we call them rate of reaction.
With the quantities measured in grams or centimeters cubed and time in seconds.
So to reaction, quantity can be measured in grams if I'm measuring mass, and can be measured in centimeter cubic if I'm measuring volume or liter, whatever. So the amount of products formed and amount or quantity of reactant used, any one of these can be measured by grams or centimeter cubic depending on what I'm using, volume or masses.
For example, if we knew that our magnesium and acid reaction produced 180 centimeters cubed of hydrogen in 2 minutes.
He give you an example in the reaction between magnesium and acid. If we hydrogen gas produced, this is the products, 180 centimeter cubic of hydrogen gas, this is volume of hydrogen gas produced in 2 minutes. What is the rate of this chemical reaction? What is the speed of this chemical reaction? I will divide the volume of products divided by the time. Quantity of products formed, that's 180 cubic centimeter, divided by time taken.
Then, because hydrogen is a product, we would use our product formed equation and do 180 centimeters cubed divided by 120 seconds. Because remember, we have to convert our 2 minutes into seconds, which would give us a rate of 1.5 centimeters cubed per second. Alternatively, if we had used 3 grams of magnesium and would hold
for the same graph, for the same equation, for the same reaction, we will change it. Instead of using the amount of hydrogen produced, this one product, we will use the amount of magnesium, which is a reactant. We can use any one of them to figure out the rate of chemical reaction.
That it took 4 minutes to disappear completely and get used up. Then we could use the other equation and do 3 grams divided by 4 times 60, so 240 seconds, which gives us 0.0125 grams per second.
Here we're using another unit because we use grams. Instead of volume, we used what? Grams. But grams of what? Of magnesium. So you can use products or reactants, you can use gram or volume. Whatever you're using, in the end, we will find the rate of chemical reaction. You can find it by 2 equations. Any one of them will give you the rate of chemical reaction.
Now, these rates of reactions that we've calculated so far are actually the average or mean rates of reaction throughout.
So this, we call it, what we just described right now, explained, is called average or mean rate of chemical reaction. Why is that? Because the rate is not constant all the time. Sometimes it has a highest point and sometimes it has a low rate. So the rate is not constant all the time during the reaction. That's why we call it the average rate. The total amount of hydrogen formed, the total amount of magnesium consumed, divided by time for the reaction. So we take the whole amount divided by time. That's why we call it average. Inside this reaction, during the reaction, sometimes you will have high rate, low rate, and changeably rate. So it's not stable or it's not the same rate all the time during the reaction. That's why we calculated the average or mean rate of chemical reaction.
The entire reaction. In reality, the rate would start off really fast when there are loads of reactants that can react together, and then slow down as the reaction progresses and the reactants get used up. We can actually see how this works by plotting some graphs with time on the x-axis and either mass of reactant remaining or volume of product produced on the y-axis.
Mass of reactant remaining. Mass of reactant, the remaining reactant, not used reactant, the remaining. And here volume of product produced. Let's see how it works.
So on our left graph here, if we started with 3 grams of magnesium, then the mass of our reactant would start at 3 grams and at first fall quite rapidly. But then it would slow as the reaction progresses and it gets used up less quickly.
So in the first, the rate was so quick because it's too steeper here. And in the end of the reaction, it was not steeper as the beginning of the reaction. So you didn't have the same rate of chemical reaction. In the beginning, it was so fast because we have a lot of the condensation or the concentration of the reactants is so high. That's why the rate is very fast. The rate is very fast. When you come closer to the end and the concentration of the reactant decreases, the rate of the reaction becomes less steeper, much less steeper. So this is mass of reactants. We started at 3 grams and this gram started to vanish until it becomes 0. at the end of the reaction, which means they completely 3 grams of magnesium reacting with HCl and vanishes in the end. Vanish and produces in the beginning of them, and instead of them, products started to appear. So with the first one here, mass of reactant, again mass, not volume, mass of reactants. And here we represent volume of product produced, volume of hydrogen. In the beginning it's 0, then it will start to increase. Let's see.
Meanwhile, for our other graph, we know that at the beginning of the reaction, we have no products, so it starts at 0. However,
because in the beginning there is no product, so we will start at 0. Okay, guys, we start from here. But here in the products, we started with not 0, we started with the initial amount of reactants. But in the products, we'll start from 0 because in the beginning of the reaction, there were no products.
it increases as lots of hydrogen is produced.
Again, this rate is so high, like exactly this rate. You will find they are the same rate. This rate is exactly like this rate. And after this, it will slowly decreases. The rate will slowly decrease until it becomes 0.
The beginning of the reaction. Then, as the reaction progresses, the graph becomes less steep and finally starts to plateau as you run out of magnesium.
When you run out of magnesium, it will give you a straight line, as you see like this. A straight line. Okay? In the beginning, you have a very steeper line, a very steeper graph, because you started with a high condense or a great amount of reactants, and the reaction was so fast, and that's why the graph was so steep in the beginning, and also here in the beginning was so steep. After consuming the whole magnesium, it becomes less steeper here, and then it gives you a horizontal line when you completely finish the what? Completely consume the magnesium that you started the reaction with.
Now, as well as using grams or centimeters cubed per second, we can also use other units like moles or decimeters cubed per second, or even per minute.
So you can use different units here, grams or moles, centimeter, decimeter cubic or cubed. And instead of second, we can use minute and so on to represent the rate of chemical reaction.
For example, if we were told that 0.6 moles of magnesium were used in 2 minutes, then to calculate the rate in moles per minute, we would just do 0.6 divided by 2 to give us 0.3 moles per minute.
So, and this is the rate. So all the rate, you will find a magnitude or the unit of mass, unit of moles, or unit of volume divided by time. If you have this unit, time could be in minute or second. Thus, right now we're talking about rate of chemical reaction. If you have this formula or this unit, mass divided by time, or volume divided by time, or mole divided by time, all these are units of rate of chemical reaction.
So it really isn't any different to before. You just have to be careful about which unit they want the answer in. Anyway, cheers for watching.
So we have reached to the end of that. So guys, let me start with this. I'll give you a question on that, or a quiz on that, but let me first rates of chemical reaction, that's it. Before we go to read rates of reaction rates, we will go to take a small quiz on that. Small quiz on that. Then we come back to read what we have here in this lesson.
Mister,
Yes,
you're not sharing your screen.
I will share it right now. Just 1 minute. I will give you some question. You may know it. You may not don't know it because we didn't take the whole parts of the lesson, but that's okay. Finish this one and then let's come back to do it. And I'll send the code. This is that's the pin. And that's the link. Use any one of these ways, the link or the pin, to join the test. Do it several times, more than one time, guys, until you figure out what are the right answers. Then we come back to read.
Again?
What? So we'll start right now.
Start.
Okay.
Again, Mister, what you said?
I will share with you the screen. Wait. Do it several times. Do it several times. If you have some mistakes, repeat it until you get the full mark.
Mister, what is a catalyst?
What do you say? What did you say?
What is a catalyst?
A catalyst is a substance that increases the rate of chemical reaction without used in the reaction. We will talk about it in the. For example, we put platinum in the reaction of formation of, for example, copper oxide, and this increases the rate of chemical reaction. And again, this one is taken away from the chemical reaction. So it's any substance like enzymes in your body, for example. Enzymes in your body increases the rate of biological reaction in your body. Then it's not consumed up. It's used again in chemical reaction.
Mister, why does volume does not affect of reaction but surface area can?
Wait, Muhammad. What did you say again?
Why does surface area can affect reactions while volume can't?
Muhammad, all of this will affect the reaction, but we will take it individually when we read the lesson. So just know the answer, and then we come to read the lesson, you will understand each one of these. We didn't take it yet. These parts, I said that we didn't cover the whole lesson. We'll cover it when we come to read the lesson. So solve it again until you know the answer, then we'll come to see the explanation for all this.
Okay, sure. Finish, Mr. 14 out of 16.
What's your mark again, Muhammad?
14 out of 16.
That's great.
Mister, can I do it again?
Mister, I got 13.
13 out of what?
13 out of 16.
15 out of 15, huh?
Out of 16.
Out of 16. Okay, that's good, not bad. You can repeat it if you wish.
How can we repeat it?
From the code. This is the code in front of you.
What
8855.
happened if I repeat it?
But I will change my name because if I
Yes,
enter the
change your name.
same.
Write 1. Write Muhammad Abdul Baqi 1 or 2.
Okay, Muhammad Al, then Saiful Qadir.
Huh?
Okay.
Yes, okay, do it.
Teacher,
Yes.
if we do this quiz and get high mark, what do you do?
This participation.
Okay.
Ibrahim Amr.
Is there is a new quiz for us because we get a bad marks in quiz
Yes.
yesterday?
After finishing this one, we'll read a little bit about the lesson. Then we'll take a new quiz.
A new quiz?
Yes.
I'm done.
Like yesterday? Okay.
Mister, I got 14 out of 16.
Yes, you can repeat it.
Mister, I got 16 out of 16.
Bravo. Who's talking? Who's talking?
Abdulaziz.
Abdulaziz, great Abdulaziz.
Abdulaziz.
Mister, I have finished. I take 16 out of 16.
Excellent, excellent voice. Let's wait for the rest.
16 out of 16, Mister.
Bravo. Excellent, guys. Yes, we have lots of
Sir, I'm
people
done.
here.
Sir, I'm done.
Like a 13.
Okay, that's enough for the quiz, guys. Right now, we'll end it. %, that's a great. Let's go here and pick someone to read.
Mister, can I read?
Wait. Okay. Ahmed Ghanas, want to read?
Yes.
Just 1 minute, Ahmed, so I can take the action. Yes.
Chapter 8.
This is chapter 7, lesson 4. If we have time, we'll take chapter 8, inshallah. Ahmed Abdul Ghanas. Okay, Ahmed. Go ahead and read this slide, the first slide here.
Okay. You may heard about athletes burning calories when they exercise. A calorie is a unit of energy used in the field of nutrition. The average banana contains about 100 calories.
So you eat carbohydrates to have calories or energy that you can use it. But to have this energy, the food must go through a series of chemical reactions. These chemical reactions take so long time unless we use enzymes to increase the rate of chemical reaction. As you read it before in the quiz, it's called catalysts. Thank you, Ahmed. And right now it will be Abdurrahim Adel. Abdurrahim Adel. Adham.
Yes.
Okay, Adham will read with us. Okay, Adham. Read this slide, Adham. Adham, you hear me? Read this slide.
If you eat a banana, you provide your body with about 100 calories to burn. This energy is released in a series of reactions that take place inside your body. A much faster way of releasing the energy contained in a banana is to burn it outside the body in a combustion reaction. The total amount of energy released is the same in the both causes.
In the both cases. Yes, if we take the energy in the banana and we burn it outside the body, okay, this would be a very fast reaction. In the body, if we digest it and take the energy out of the banana inside your body, we will have the same amount of energy because we have the same banana. But outside the body, burning is so fast. So we're talking about how fast a chemical reaction can happen. It can happen the same chemical reaction in different rates. Depending on the circumstances the reaction is occurring in. And someone, Mr. Adham, Ahmed Mustafa not answered, and Abdurrahim Adil absent. Let's go. It's not moving. Okay, yes, that's it. علي يوسف الهلال، علي يوسف جابر الهلال، فيصل.
Yeah.
Okay, Faisal, I want you to read this slide, please.
Reaction over time.
No, this one. Yeah.
Okay, reaction over time. What does a reaction rate tell you? A reaction rate is the rate at which reactions change into products over time. Reaction rates tell you how fast a reaction is going.
Yes, it's going. This is the rate of chemical reaction. Read this too, Faisal, so we move quickly. Reaction over time.
Okay, do you want me to read it?
Yes, Ashan. Just
a reaction over time. Any change that happens over a period of time can be expressed as a rate. The reaction rate is how fast the reactants are being consumed, how fast the products are being formed, or how fast energy is being absorbed or released.
So this is how fast the chemical reaction happen. We calculated by the amount of reactant consumed or the amount of product produced. This is how to calculate the change in chemical reaction or the rate of chemical reaction. And pick someone else. Hassan Ramadan. Hassan Ramadan is here. Ibrahim Adil.
Yes, Mr.
Ibrahim. طيب. Hassan Ramadan is here. Okay, Hassan, I want to read this slide. Read it, Hassan. Yeah, Hassan.
Mr. Can I read the next slide? Muhammad Abdul Qadir.
Yes. I will take someone else. Hassan is not answering me. So Hassan not participating.
Hey,
Mr.
He said in the chat, wait, Mr. I have noise.
Okay,
yes.
No problem. Ibrahim Adil, read this slide. Read this slide. What factors?
What factors cause the reaction rates to change? Factors that affect reaction rates include temperature, surface area, concentration, stirring, and catalysts.
So this is the actual factors affecting the chemical reaction. We have temperature, we have surface area, we have concentration, and we have stirring and catalyst. 1, 2, 3, 4, and 5 things that affect chemical reaction. We will not talk all of them. We'll just talk about a little bit of them. Muhammad Abdul Qadir, read this one.
Yes, Mr. Factors affecting reaction rates. The reaction rate of a chemical reaction depends on how often reactants particles collide. If the collisions occur more frequently, then the reaction rate increases. If the reaction occurs less frequently, then the reaction rate decreases. Reaction rates can be changed by varying conditions.
So this is the main idea here for the reaction rate. Number one, the reaction rate of a chemical reaction depends on what? How often reactant, not products, particles collide. If they collide too often, the reaction rate will be fast. If they collide less frequently, it will be too slow reaction. So the collisions occur more frequently between reactants, then the reaction rate increases. The collisions occur less frequently, then the reaction rate decreases. Reaction rates can be changed by varying conditions. We will stop here and give you a quiz, guys. We will take these factors in the next session, inshallah. But right now, I'll give you a quiz on these factors again, and tomorrow we'll continue with reading this part. So I'm going to give you another quiz.
Okay.
Does this quiz have marks?
No, it's only for participation.
Can I ask a question, Mr. Muhammad Abdul Qadir?
Yes, you can.
The question is how powder increases surface area from question in the quiz.
You increase the surface area of reactants by making it powder. You make it, instead of making cubes, Powder increasing the particles on the surface. That's why you have more collision between reactants and you increase chemical reaction. So
how about concentration? Because you make powder in a very small area also.
No. Concentration means the amount of reactants. The amount of reactants. If you have more reactants, concentration increase of reactants, this means more collisions. More collisions mean what?
More frequent, more rates.
More rates, yes. More cookshare, yes.
Okay, how about volume? Why does not volume affect rate of reaction, while surface area can?
No, surface area represents the particles itself. Okay, the volume could be the same volume, but you increase the particles on the surface. That's the main idea. If you have more particles on the surface, this means more collisions, and this means more collisions mean what? More reaction rate or faster reaction rate. I just want this to upload. You're welcome, Muhammad.
Mr. Still 5 minutes.
This is the same quiz. So I hope that you finish it quickly. Then you can leave. No problem.
Quiz?
The same
Yes.
quiz. I do it.
You want someone else? So I will delete this one. I'll give you another one. Okay, 1 minute. I will give you another one. Oh, you entered. So use it, guys. Use it. It's okay. Use it.
Okay, I entered the new one. I'm sorry, mister. I am very ashamed, but what does catalyst mean again?
Catalyst, a substance used to increase the rate of chemical reaction, but it's not used in the reaction. We'll take it in details. Okay? Tomorrow, inshallah. Okay, let's start the reaction.
Can I read?
No reading. You will do the quiz tomorrow, inshallah. And I want, after finishing the quiz, if you get the full mark,
Okay,
if you
Mr.
got the full mark, leave.
Mr.
If you get the full mark, you can leave, guys.
If I don't get the full mark 4 times.
Repeat it.
Mister.
Yes.
Tomorrow is a test.
No, not the test. Test is on Wednesday on Tuesdays only.
Ah, okay.
Mister, this is the same test.
Mister, I have finished full mark. Can I leave?
Yes, if you finish, you can leave.
Mister, I got 15 out of 16. Can I leave?
Yes,
because I was too fast.
And you got full mark, you can leave.
I was too fast. I was going to answer the correct full mark, but too fast. Mr. Can I leave?
Yes, you can leave.
Thank you.